Yo, yo! Here are our chord notes. So, section 10.3, chords on a circle. What is a chord? It is a line, and I should have wrote line segment. So if you want to add that in, it's a line segment that has both endpoints on the circle. So endpoint A, boom, endpoint B on the circle, and there it is. That is a chord. Why is it a chord? Because both of its endpoints are on the circle. There you go. So AB is a chord. Now there's three things that we're going to learn about chords. And the very first thing is that congruent chords. So let's look at chord NM right here and chord PQ. And let's say that those two are congruent. So we'll put our little tick marks there to show that they're congruent chords. So if the chords are congruent, then a bunch of fun things happen. And the first fun thing that happens is that if the chords are congruent, then I know that these central angles are congruent. So angle MTN is going to be congruent to angle PTQ. So if the chords are congruent, then the central angles are congruent. Easy peasy. No big deal. And it kind of makes sense. I mean, check it out, dude. And the way that works is from a little side congruence. If I had one, well, these are both radiuses, right? This section right here is a radius. This section right here is a radius. And I know that the radius is going to be the same everywhere on a circle. So I go put these little tick marks here to be like, hey, radius, you're the same. And then I have this chord, and it's going to be matching that other chord. So if that's happening, and then I've got this other triangle formed by the two radiuses, which have to be the same length, and that chord that matches the other chord, then I would say that these two triangles are congruent by side congruence. So if that's true, then all their parts are going to be congruent, including these central angles right here. So if the chords are congruent, then the central angles are congruent. Boom! Kind of makes sense. It kind of just feels right. And then conversely, which means flip it around, if the central angles are congruent, then the corresponding chords are congruent. Boom! So it goes both ways. It says, hey, these angles are congruent. So if those angles match up, then the chords that go along with them match up too. So no big deal there, just some matching stuff. And then in the next piece, a very similar idea. If the chords are congruent, so I have, oh sorry, I'm reading it backwards. If the arcs are congruent. So we're looking at arc NM. Here it is, arc NM. And it's supposed to be congruent to arc PQ. So those two arcs are the same. Well, that to us means that their chords are going to be the same. So we call those arcs intercepted arcs. Intercepted arcs, just in case you see it later. Intercepted arcs. So congruent intercepted arcs means the corresponding chords are congruent. And you know what that would mean, according to what we just learned, that the central angles that go with them are also going to be congruent. So we're going to be able to put all of these things together. So the first one said that if the chords were congruent chords means congruent central angles. The second theorem says congruent arcs. Oops, spelled arcs wrong. That's weird. Means congruent chords. And the converses are always true, so you could go backwards as well. Congruent central angles means congruent chords. Congruent chords means congruent arcs. So it's all going to be related. And let's look at the next page. On the next page, it says if chords are ooh, a little bit different. Okay, if chords are equidistant from the center. So we put this little chunk of radius here to show that it's equidistant. It's the same distance from the center as that chord. So DC is the same distance from the center as AB. And it's shown using that little SF and SE. That's to show that they're equidistant. So if the chords are equidistant from the center of a circle, or the centers of congruent circles, then they are congruent to each other. So what it's saying is if DC is equidistant, according to that tick mark, same distance as AB from the center, then DC and AB are going to be congruent. So DC and AB are going to be congruent. So equidistant means congruent chords. All right, and then conversely, so conversely should be the backwards of that. The congruent chords should mean that they're equidistant from the center. So conversely just means flip the statement around, which I did. All right, guys, so that's all the stuff that goes into what we're gonna do, but we got to think about it a little bit deeper. Like how are we going to use this information? So think about what you could do with this. What we're going to do is we're going to talk about this right angle, and that's going to help us because we know so much about right angles, and specifically, if I draw a radius here from A to S, I know a whole lot about right triangles. So in this topic, we're probably going to have to use some right triangles. We're going to talk a lot about congruence like we saw on the first page, but then we're also going to talk a lot about right triangles. So we can make a right triangle and the first thing that pops in my head when I hear about right triangles is little a squared plus b squared equals c squared. So we're probably going to have to use that in this section too. In fact, I don't think there's a topic that we're going to learn where we don't use Pythagorean theorem. All right, guys, so that's a little introduction to what we're going to do. I've got more videos that are going to explain examples and help you out with some of the quizzes, but that's just like an overview of all the stuff in this topic. Alrighty, see ya!